Okay, so let's see some important questions from moment of inertia. Okay, these are the important previous year questions as well as concept also, so you can directly remember them. So now if you're talking about solid hemisphere, okay, solid hemisphere. So multiple axes I have drawn here about which we have to find I1, I2, I3, I0, all those axes we'll find. Okay, so let's see. So it's a solid sphere. First thing that we can remember here is this one. The hemisphere has a center of mass about how much distance above 3r by 8. Okay, so x is here is 3r by 8. So from this center of mass, if I talk about the top vertices, top distance, it would become 5r by 8. Total distance is r. Okay, this point clear. Next one, moment of inertia of this hemisphere about this base axis I2, that would be same as the solid sphere, 2 by 5 mr square, because of this symmetrical cut. Okay, so 2 by 5 mr square. Okay, that's not a big deal. Now let's apply the moment of inertia parallel axis theorem. So for parallel axis theorem, we know that we have to take the moment of inertia about the center of mass axis I0 and then mass into distance square. So now I0 plus mass into distance square will come to the I2. So I0 plus mx square is I2. Okay, I2 we already have 2 by 5 mr square. So I have put the value of I2 2 by 5 mr square. So I0 would become this much. Now we can solve it also, that also we can remember easily. Important point is about I3, about the top. So now for the I3 again we'll apply the same parallel axis theorem from the I0. So I0 plus mass into this distance 5r by 8 square. So I0 plus mass into 5r by 8 square, that would be what? I3. I0 we already have here 2 by 5 mr square minus 9 by 64 mr square plus this one would become 25 by 64 mr square. So after doing the calculation we'll get how much? I3 moment of inertia about the third axis would be how much? 13 by 20 mr square. That's, you can remember it as an important result. Okay, put it down in your notebook. Okay, now one more axis remains. The axis is this one, I1, passing through the center only, but it is making angle how much? 30 degree. Clear? Okay, so let's see for this also. So for this what we will do now, see I have drawn here, I have shaded the regions. So this is the part. Suppose if I remove this part and add a symmetrical part here. So if I remove this part and adding a symmetrical part, because I'm not disturbing its distribution, I'm adding the same mass here or there, like suppose m mass is here or m mass I place here at the same distance or symmetric distribution, so moment of inertia is not going to change. So if I remove the yellow portion and add the gray portion, no change would happen. Now if you see this portion that I am coloring at this moment, I am shading at this moment, right? So this portion, it would become what? It would become nothing but a hemisphere, and hemisphere about this base is what? 2 by 5 mr square, right? So moment of inertia of this given question is how much? 2 by 5 mr square. Clear? Okay, not a big deal. Next one, equilateral triangle. It's also very important type of question, equilateral triangle. So what we have done here is that I have taken an equilateral triangle. Okay, it's a triangular lamina which is equilateral. Mass of this one m, length is l. Clear? Mass of this equilateral triangle is what? M, length is l. So if I write its inertia about the centroid, so it will become some of the form, it would become gamma ml square, some constant into ml square. It is going to be of that form, right? Now see, I have added 3 more laminas such that if I talk about what was the initial figure, equilateral triangle. Okay, now after adding symmetrical distribution, what it remains? It remains an equilateral triangle only, no? So the formula would not change. If this mass is m, so all of them mass would be m, so total mass would become how much? 4m. Original length is l, so this length l, this length l, so final length would become how much? 2l. So if I say that I dash is the moment of inertia of the final distribution, so it would be of the same form. Gamma mass would become 4m, length would become 2l, so whole square, so it would become 16i. Okay, so I dash would become how much? 16i. That's clear. Now again, if you talk about this point and this point, these are the centers, so distance between them that can be easily calculated. X here, it would be 2x, where x value can be calculated using trigonometry. So x value would come out to be L by 2 root 3. Now let's see. I dash is what? I dash is the moment of inertia of the whole system. So now I'm going to write it using parallel axis theorem. So I dash would be I moment of inertia of this inner triangle, and then this one. So for this outer triangle, the centroid is here. From here I will change it. Okay, now one more point here. If I talk about the moment of inertia of this triangle, about its centroid is I, so this triangle about its centroid would also be how much? I only, because obviously equilateral triangle, about the centroid perpendicular, so it would remain I. So I dash I am going to write again for the total, so it would become I, that is the center one, plus how many triangles are there? 3 triangles. So I have multiplied, I have taken, because all the cases are symmetrical, so directly I have taken 3 here. Okay, 3 times inertia I of this triangle plus mass into distance is how much? 2x. Distance is 2x. So 2x, if I calculate here, it would become L by root 3. So 2x square. So L square by 3 I have added. This is for the 1 multiplied by 3. So after calculation I would get how much? I equals to ml square by 12. Very very important formula. Directly what you will remember, I have a triangle, equilateral triangle, about the centroid perpendicular to the plane, ml square by 12. Got it?